All right, we're going to work again today on factoring quadratic trinomials. We're going to build on some of the ideas we had yesterday by making that table of values that allowed you to look at for the right combination of numbers that would allow you to create two binomials when FOILed would equal the original trinomial. Okay, so what we're going to do today is add a little to it, and the addition here is our coefficient now is not going to be a 1, our lead coefficient. So if you remember all your examples from yesterday, there was no number here. It was just n squared plus 16n plus 24. So you didn't have to worry about this first number. Now you're going to have a number here in this position, and now we got to deal with that number. The first thing we're always going to do, regardless of how many terms there are, is always look to factor out the GCF first. Now that there's a number here, we're going to look for GCF. So as I look at this example, all right, each of these terms, three terms, can be divided by a 2. So I'm going to factor that 2 out first. All right, so 2 times the quantity of n squared plus 8n plus 12 is equal to the original trinomial. Now at this time it has been factored because we have now written this trinomial as a product of a monomial by a trinomial. So this is factored, but we always have to completely factor. So what we'll do now is we're going to factor the trinomial that's inside the parenthesis. We're going to do what we did yesterday, okay? So I'm going to set my table up as n squared and n in their columns, and then we want to get at 8n from the combination. Okay, so we know the only way we're getting n squared is n times n. Now for 12, there's a lot of choices. 1 times 12, 2 times 6, 3 times 4. So I just stuck 3 and 4 in there to show you that 3 times 4 does equal 12. And then when we multiply across and add down, we get a 7n. Well, again, our target was an 8n, so this is not the right combination. So the next one we move to, the next choice here, I'd go with 6 and 2. Okay, 6 times 2 equals 12. Now multiply across, I get 6n and 2n, and that's my 8n. All right, so this is the correct combination right here, n, 6, and 2. Okay, now when I go to write this, I just want you to see here. Here's the original trinomial. Notice now in my factored form, I'm bringing that 2 in front. That 2 came from right here. I already factored the 2 out, and when the 2 got factored out, I got this result. So I have to put the 2 here, and then I still place in things the way we did before. The n's go first, the 6 and the 2 come second. Okay, so this is the factored form for the original trinomial. Now, just to show you how we can FOIL it out and look at our result, let's take this 2 times the quantity of n plus 6 times n plus 2, and let's multiply this out, and we should get this back as our answer. So what I'm going to do is leave the 2 out front, okay, and I'm going to FOIL these two. I'm going to multiply these two binomials together, okay? So I'm going to FOIL this, n times n squared, n times 2, 2n, 6 times n, 6n, 6 times 2 is 12. And now let's take what's in parentheses and simplify it. This 2n plus 6n is 8n. Okay. Now, this is a monomial times a polynomial here, or trinomial. So let's just distribute that 2 through. And if I do that, I get 2n squared plus 16n plus 24. And that was my original trinomial. Okay. So this right here that I'm circling is the factored form. That's the correct factored form for that trinomial. Okay, so take the GCF out first, and it's got to stay part of the factored chain there, as you will. Okay, let's look at this one. So 4x squared plus 12x plus 28. Okay, if I have a number as a coefficient here other than 1, then I'm looking to take out the GCF first. So what can all of these be divided by? Well, they can all be divided by a 4. So I'm going to pull a 4 out. Okay, that'll make this x squared plus 3x plus 7. If I distribute the 4 back through, I get the original. Okay, now, as we did before, we're going to try to factor the trinomial that remains inside parentheses. So x squared 7. We want to make that should say 3x, guys. My apologies there. We want to make 3x. Now, realistically, that's not going to happen. We're not going to be able to make 3x because the only way you can get an x squared is x times x. The only way you're going to get 7 is 1 times 7. So it could be 1 here, 7 here, or 7 here and a 1 here. No matter how you do it, this is going to give you 8x. Well, we remember that shouldn't be there. We didn't want 8x, we wanted 3x. So there's no way we can factor this one. So this trinomial in parentheses is prime. It can't be factored anymore. But we would say that our factored answer is that 4 times that trinomial that we pulled out. So we would write our answer like this. This is factored. We just didn't get a chance to break this trinomial down any farther. Okay, so that might happen. Okay, let's look at our next one here. 2x squared plus 9x minus 5. Okay, first thing we look for is a GCF. Do we have a GCF? 2, 9, negative 5? We do not. So we'll set up our table and go to work. The nice part about this one, well, first of all, that's got to be a 9x, right? Our combination here has got to be a 9x. The nice thing about these numbers is the only way you're getting 2x squared is 2x times x. Okay, whether that's an x and that's a 2x or vice versa, this is your only combination. The only way you're going to get an answer of 5 through multiplication is 1 times 5. Now, there's actually a couple of variations, right? There's negative 1 times positive 5 or positive 1 times negative 5. And switching the order of these two with this multiplication combination makes a difference. But let's just stick them in this order and see what happens. So 2x times negative 1 is negative 2x. X times 5 is 5x. When I add those together, I get 3x. We wanted 9x. So you got to start thinking to yourself, mentally, how could I switch this around? And essentially, if we just switch around the 5 and the negative 1, put the 5 on top, negative 1 on bottom. Now, it does matter the order here, right? Because we're going to multiply across. So look what happens. 2x times 5, that's 10x. X times negative 1, that's negative 1x. And if I add 10x and negative 1x, I get 9x, and that's what we wanted. Okay? So this is the right combination. Now, when I go to put it in my grouping symbols, I do have to do a little extra work here. Okay? Because of the way we FOIL, when I go to put these in, I actually want to cross group them. And what I mean is this. I want the 2x and the negative 1 to go together in a parenthesis. They go to one parenthesis. Okay. I want the x and 5 to go in the other parenthesis. Okay. The reason we do that is because of the FOIL process. Okay. Look at what happens here. If I take 2x minus 1 times x plus 5, okay, 2x times x, 2x squared. Now I'm going to do 2x times 5. That's my 10x. That's that 10x right here, 2x times 5. Okay, now I'm going to go negative 1 times x. That's this one right here. Negative 1 times x is negative 1x. And then I'm going to do negative 1 times the 5, and that's the negative 5. That's this multiplication, right? Simplifying this, 2x squared plus 9x minus 5 is what I get when I multiply these two binomials together. So those are the correct factored combination. That gives me back my original trinomial when it's FOILed. So this, guys, is the answer we're looking for right there. 2x minus 1 times x plus 5. So you got to remember to cross group. We'll do some more of these here. Okay, so another one. 2z squared minus 20z minus 3. First of all, is there GCF? 7, 20, and 3? Nope, nothing divides all of those evenly. There's no common variable, obviously. So we begin our chart. 7z squared negative 3. Again, there's really only one combination to get 7z squared, and that's going to be negative 7z times z. There's only one combination to get a negative 3. Well, there's a few, right? It's 1 times negative 3 or negative 1 times positive 3. So we'll just stick in negative 1 times 3. Now, I got to highlight this. We're trying to get a negative 20z, right? We're always trying to get that middle number in our combination. So let's go ahead and multiply across. 7z times negative 1, z times 3. Add them together, negative 4z. We wanted negative 20z, so it's not the right combination. Now, just doing a little mental work here, I know 3 times 7 is 21 and 1 times z is 1. So 21 and 1 have a good chance of getting us that 20 we want, right? So let's switch these around and make it negative 3 times positive 1. The negative 3 on top makes a difference because when I multiply across, 7z times negative 3 is negative 21z. Z times 1 is z. And when I add that together, I get the negative 20z that we want. Okay, so right here is my combination. That's the one I want. All right, So again, when I go to put it in parentheses, I got to cross group it to get the combination right. So the 7z and the 1 are going to go in the same parenthesis, okay? And the z minus 3 is going to go in the other parenthesis. You got to cross group it to get it to come out right when you FOIL it, okay? Just to show you that FOIL process now. First, 7 times z, 7z squared. Outers, 7z times negative 3. That's this one right here we wanted. That's negative 21z. Inside, guys, 1 times z is 1z. And then last, negative, or excuse me, 1 times negative 3 is negative 3. And now combine my like terms, and we have our original trinomial back. So the product of these two binomials, that's my answer. That's factor. Remember, factor is to multiply binomials together to get the original. Okay. Another example. Okay. There's no GCF, so I don't factor anything out to begin with. So I'm jumping right into my little table here. All right. We got 3z squared, negative 24, and we want to make a 1z, a positive 1z here in the middle. Okay. 3z squared, there's only one way to get it, 3z times z. Now, negative 24, man, there's a whole bunch of ways you can get that. 1 times negative 24, negative 1 times positive 24, 2 times negative 12, negative 2 times positive 12, 4 times negative 6, 6 times negative. So there's all kinds of combinations here. Okay. What I see is I want to get a 1. So I want to kind of get a really small number. So I'm thinking these numbers should be close together. So I'm going to go with a negative 3 and an 8. Okay, 4 and a 6 would have been a good choice too, but you just got to maybe guess to get started here. So I know negative 3 times 8 is negative 24, and I know 3z times z is 3z squared. Now let's see what happens when we multiply across. I'm going to get a negative 9z and an 8z, and that's going to give me a negative 1z. Well, I didn't want negative 1z. I wanted positive 1z. So that's not right. So what I'm going to do is I'm going to try 3 on top and an 8 on the bottom, a positive 3 on top and a negative 8 on the bottom. So what happens here now when I multiply across, I get positive 9z. That's going to give me negative 8z, which is my positive 1z. That's what I wanted, right? So here's my correct combination. Now we could have tried a whole lot before we hit on this one. Sometimes you do a little mental work to try to figure it out. All right. Sometimes it takes a few guesses, but you will get to it eventually. Okay. And the more you do it, the faster it'll come to you. Now, remember, when I go to put in my parentheses, cross group it, right? So the 3z and the negative 8 have to go in the same parenthesis, and the z and the 3 have to go in the same parenthesis. Okay. And that's to get that FOIL combination right. So I get that middle number right. So let's just go through that here. That should say a z, right? 3z times z is 3z squared. 3z times 3, 9z, negative 8 times z, negative 8z, negative 8 times 3, negative 24. Combine my like terms, and there I am right back at my answer. Okay, so right here, this binomial times this binomial, that's the factored answer we want. Okay, I think I got one more here. All right. So process is the same over and over. Is there GCF? 6, negative 17, 12. Nope, there's nothing I can take out of all three as far as a number goes, as far as factoring out a number for starters. Okay, so let's go to our table. 6y squared, 12, and I want to make negative 17y. Okay, now there are some combinations here now to get my first term. I could go 6y times y. I could go 3y times 2y. So I got some combinations to work with there. And then here, I want 12 to be positive, but notice I got a negative number in the middle. And if you remember what that meant was these two are going to have to be negative to give me a positive 12 and then give me some negatives to work with in the middle. Okay, so I'm gonna guess 3y, 2y, and negative 4, negative 3, just for starters, see where I'm at. Okay, so I know negative 4 times negative 3 is 12. I know 3y times 2y is 6y squared. So multiply across. Negative 12y, negative 6y, negative 18y. Well, we wanted negative 17, so that's not it. Okay, I'm going to stick with 3y, 2y. Now I'm going to go negative 3 on top, negative 4 on the bottom. Does that make a difference? Well, yeah, because you're multiplying across by different numbers now. Okay, so what's 3y times negative 3? Negative 9y. 2y times negative 8, or excuse me, negative 4 is negative 8y. Add those together, there's our negative 17y. So just flip-flopping these two made the difference, right? So now when I put them in my parentheses, my two binomials, I got to cross group it. 3y and negative 4, 2y minus 3. Okay, just to test it, just to show you that we got it right. I know this binomial times this binomial equals this trinomial. I'm going to FOIL it to prove it, right? 3y times 2y, 6y squared. 3y times negative 3, negative 9y. Negative 4 times 2y, negative 8y. Negative 4 times negative 3, positive 12. Combine like terms, we got her, right? This product of these binomials, which is now factored because it's a binomial times a binomial, equals that trinomial, okay? All right, so those are the ones you're going to run into tonight. So you want to work on taking out that GCF first. Once you got the GCF out, then go to work on setting up your table, your little T-chart there, work it through, get the right combination, and write them out correctly. All right, I'll let you get going.